Hello everyone. So today we are going to have a brief explanation or discussion on the theory of probability. So let's have a look on what is probability and what all are the important terms in the probability theory and what do you mean by the additional rule of the probability. So the word probability is a commonly used word in our daily conversations. We may make statements like probably he will get a job or probably it will rain tomorrow or possibly it will rain tomorrow. So these words like likely and possibility convey the same meaning of probability. So these sentences are used when we are not sure about the certainty of a happening of a particular event. If we are not sure that whether it will happen or not, then we will use these statements like likely or possibly or probably. And in some scenarios, we may use the probability to predict the events. Some events we are not sure, we may use the prediction, use the likelihood of the occurrence of the events. So let's have a look on what is probability. The probability of an event may be defined as a numerical value given to the likelihood of occurrence of that event. I've already explained you that it define the likelihood of the occurrence of that event. How much possibility or how much probability is there to an event to happen. And it is a number lying between 0 and 1. This is very important in probability that the probability will be always lies between 0 and 1. It should not be greater than 1 or it should not be less than 0. So the probability value should be always lies between 0 and 1. And next is 0 is for an event which cannot occur and 1 for is an event certain to occur. 0 will be applicable to a not certain or not happening event and 1 will be applicable for a certainty event. And next is we have the formula of the probability. The probability is equal to number of favorable outcomes divided by the total number of outcomes. Suppose for example, when we are throwing a die, the possible outcomes are 1 to 6, that we may get 1, 2, 3, 4, 5 or 6. So from that we have to know the probability of getting an even number, then the probability will be 3 by 6. The 3 refers to the even numbers. We have 3 even numbers, 2, 4 and 6. So the number of favorable outcomes will comes on the numerator, and in the denominator we will have the total number of outcomes. So the probability of getting an even number from a die is thrown as 3 by 6. Okay, so I hope that you got an understanding about the formula of probability, that is number of favorable outcomes divided by the total number of outcomes. Next is we are going to analyze, so we are going to familiarize with some important terms in probability. The first one is the random experiment. It is an experiment that has two or more outcomes which vary in an unpredictable manner from trial to trial when conducted under uniform conditions is called the random experiments. So in case of a random experiments, we will have two or more outcomes which may not be predictable. We are not sure that which outcome will going to happen. But we may know the all outcomes in advance, but we are not sure which outcome is going to happen. And next is the sample space. Sample space is the set that from random experiments we are getting the sample space. It is a set containing all the possible outcome of a random experiment. In case of the die thrown, we have already discussed that sample space will be 1 to 6. That is a possible outcome of a random experiment from 1 to 6. So the set containing 1, 2, 3, 4, 5 and 6 will be the sample space in a die is thrown. And then comes the event. An event is a subset of the sample space of a random experiment. An event is a particular thing, that is particularly we are taking some criteria from the sample space. In the previous example, we have already discussed that the sample event will be getting an even number from a die is thrown. So the event will be set 2, 4 and 6. Even numbers are 2, 4 and 6. So that will be the event constitute when a die is thrown. So event is a subset. That is very important. Event is a subset of the sample space of a random experiment. Then comes the sure event or certain events. Sure events are which definitely will going to happen. These event is known as the certain event. For example, we are seeing, suppose we are taking a white bowl from a bag of white bowls. So we are sure that we will definitely get a white bowl from the bag of white bowls. So this is known as the sure events. And next comes the Impossible events or uncertain events. This is exactly the opposite of the sure events. If the event cannot occur when the random experiment is conducted, then that event is an impossible event. Suppose, for an example, when we are taking a black ball from a group of white balls, this is totally an impossible event which will not be going to happen. So this is a case of an impossible event which is not certain or not going to happen. Next is the uncertain event. An event is said to be uncertain if it is happening is neither nor impossible. So, in case of uncertain event, we are not sure whether it will happen or not. For example, suppose we are taking a ball from black ball is taken from a group of white and black balls. So, we are not sure whether we will get a black or white ball. So, this is the uncertainty event. In uncertainty event, the probability will be usually lies between 0 to 1. Next is the equally likely events. Two events are said to be equally likely if any one of them cannot be expected to occur in the preference to another. If we are tossing a coin and we are getting head or tail. We are not sure whether we will get a head or whether we will get a tail. In this case, it is like a equally likely events and which cannot be expected to occur in preference to the other. And next is the final event, that is a mutually exclusive event. These events are as shown in the diagram. These events are mutually exclusive. The exclusive possibility of occurrence of the other. Acceptive events are said to be mutually exclusive if the occurrence of one them excludes the possibility the occurrence of other. That is, A will happen. When A will happen, the B is not going to happen. This is known as the mutually exclusive event. The happening of one event will exclude the happening of the other event. And in this cases, the A intersection B will be a null set. An empty set will be got in case of A intersection B of mutually exclusive events. And then we are going to familiarize with some probability notation, some important probability notations used in the theory of probability. And the first one is the P of A. This is a probability that event A occurs. It will be specific to particular event, or P of B will be the probability that event B occurs. So P of A refers to the event probability that event A occurs. And next is the P complement. P of A complement is a probability that even A will not occur. That is, A is a complement of A. Here in this diagram, universal set is represented in the yellow portion and the circular portion is representing the event A. And A complement is the universal set minus A. We will get the A complement. Another way to find the P of A complement is equal to 1 minus P of A. So, next is the P of A union B. A union B will occur A or B or will occur both. That is a union of A and B. If two events are said to happen together, then it is known as A union B. And next is the P of A intersection B. Probability that A and B will occur simultaneously, that both A and B occur together. That is known as the joint probability of A and B. See, in this diagram, we can see that this is the A event and this is the B event and this is the universal set. And this yellow portion is referring the A intersection B. Intersection means the joint probability that in this area the A and B will occur together. So this is known as the intersection of probability. And next we have some example. Let's familiarize with some example of probabilities. It is a simple example actually. A die is rolled, find the probability that even number is obtained. So we have some steps to write, or we have some steps to find out the probability of a particular problem. The first you have to write the sample space. So in the sample space we are rolling a die, one die is rolled. So the sample space will be 1, 2, 3, 4, 5 and 6. And let be the event. E be the event and even number is obtained. So the criterion is the even number should be obtained and even numbers are 2, 4, 6. Now we can use the formula of classical probability. The formula we have seen in the first slide, that is the total number of favorable outcomes divided by the total number of outcomes. How much favorable outcomes divided by the total number of outcomes. So here the favorable outcomes are 3 and out of the 6 total outcomes we have 3 favorable outcomes. So the probability will be 3 by 6, that is 1 by 2 or 0.5. So this is a simple example explaining the simple type of probability. And next we are moving to the additional rule of probability. Let's have a look on what is the additional rule of probability. Here we are going to explain the additional rule for non-mutually exclusive events. The events which are not mutually exclusive, what is the addition rule should be followed. When two events A and B are non-mutually exclusive, there is some overlap between these events. The probability that A or B will occur is the sum of the probability of each event minus the probability of overlap. So we have to detect the overlap between. Overlap means the intersection. The intersection should be deducted from the sum of the probability of both events. So P of A or B is equal to P of A plus P of B minus P of A and B. Here the or representing the union, or is representing probability, the or is representing or implies the union, and implies the intersection. So the formula can be rewritten as probability of A union B is equal to P of A plus P of B minus P of A intersection B. So you have to take care that whenever you have seen a or and in a problem, you have to substitute that with union or intersection respectively. So let's have a look on the problem regarding the additional rule of the non-mutually exclusive events. The question is the probability that a student will pass a final examination in both English and Hindi is 0.5, and the probability of passing English or Hindi is 0.9. If the probability of passing in English examination is 0.75, what is the probability of passing the Hindi examination? So in this question we have to concentrate on these words, that is a both, or, and English. So we have both representing the and. So we have the intersection, and or representing the implying the union. So we have the union, and we have the English examination probability. So it's very easy to find the probability of passing Hindi examination. So we can apply the formula and find out the answer. Let E and H denote the events that student will pass in English and Hindi examination respectively. Then we have P of E intersection H is equal to 0.5, which is the both. And P of E union H, which is represented on R, is the 0.9, and P of English is 0.75. So we are going to apply the formula, that is P of E union H is equal to P of E plus P of H minus P of E intersection H. So by substituting the formula, values in this formula, we will get that P of H is equal to 0.65. This means that, or this implies that the student have 0.5%, so 0.5 chance to pass in the Hindi examination, or otherwise we can say that the student has a 65% chance to pass in the Hindi examination. So I hope that you all are understood with this question and the formula also. So that's all about the topic probability and some basic important terms of probability. Thank you.